So good morning. Welcome to this presentation on bridging the physical and digital worlds. So this presentation is brought to you by Analog Devices in conjunction with Anglia components. So myself, Pierre Morris, and my colleague Will Mitchell are both field application engineers with Analog Devices, with Anglia representing Analog Devices today. So there's an AI revolution on the way, right? Allowing machines to see, hear, and sense the world around them. Now, artificial intelligence is not a new concept. It's been around for hundreds of years. However, it wasn't until about the 1950s that we actually started to realize the concept of AI when researchers started to look at it a bit more strategically. Fast forward to 2022, and we see generative AI, right? What is generative AI? So we have systems that can actually produce, let's say, outputs in the form of videos, images, or even text with a few prompts from users. Now, how does that work? We need to train these systems using data sets, and a good data set is important to give you good information. So we're going to touch on why data is important. We're going to look at a few applications where ADI provides solutions for achieving good data sets for AI applications. Two of those areas we're going to touch on is vital signs monitoring, which is essentially in the healthcare atmosphere, as well as machine health, so condition-based monitoring. We're going to touch a little bit on edge AI and move on to single pair Ethernet as well as GMSL, so means of moving data from A to B. So this is not a presentation on AI, coming from the guy who's giving you an illustration of the methods used to actually program one of Analog Devices' AI low-powered microcontrollers that have a built-in convolutional neural network. The objective of showing you this slide is to show you the different stages for which you need to use to actually, actualize a AI application, but with the indication that a data set is at the early stages and very critical. You need good data to get good information. So ADI have solutions, so complete solutions, specifically within the vital signs monitoring atmosphere that you can use to get good data. So if you're familiar with Analog Devices, you will know that they have components that are very good in terms of the signal to noise ratios. In the atmosphere of vital signs monitoring, you can potentially use analog front ends that can help you to measure data for biopotential. So things like ECG measurements. You have optical sensors for PPG measurements. So you use this to, look at look at the SpO2, so blood oxygen concentration as well as heart rate. You can also look at things like, restlessness while you sleep. They have sensors that are used for ambient temperature measurements as well as, skin temperature monitoring, and electrochemical analog front ends, which will obviously be used for blood glucose monitoring, such as, for measuring diabetes. Now, it is fantastic that Analog Devices have these discrete components, but what use of it is to you as engineers, right? I'm certain you will be more happy with a complete solution that you can actually use to capture data quickly, because that's where your interest is, right? You want to get data to, actualize your applications. So I'd just like to introduce to you the Max Ref Des 106, also known as the Health Sensor Platform version 4. With this particular platform, you can measure all of the vital signs monitoring facilities, as I mentioned before. So there's PPG for SpO2. You can do ECG for heart rate monitoring and bioimpedance for respiration rate, and the list goes on. With this particular solution, this is just a demonstration on how you will be able to use it. So it's a patch that sits on your chest. This patch, you have electrodes connected to it that are used for the bioimpedance measurements. On the patch itself, there is a disc for the skin measurement. There's also another disc for the ambient temperature measurement. And it is actually quite useful to know that this particular device, you can use it to communicate with a PC. So data is sent from the patch to the PC using Bluetooth. Now, one of the key benefits of using a solution like this is that with data capture, you want to analyze the data. And as engineers, right, again, you don't want to spend too much time with just capturing data. With this solution, there are algorithms associated with it that you can have access to, which will help you to turn this data into useful information. So once you measure the data for, let's say, the PPG measurements, you can then use the algorithms to look at things like SpO2, the blood oxygen concentration. Getting the data is one thing, right? But wouldn't it be useful if you were to have a user interface to interact? Well, the good news is there is a user interface with this particular solution, and that it's probably not clear, but with this user interface, you can use it to configure that particular patch for the different types of measurements, as well as analyze the data that you have recorded. So I think this is quite useful for engineers, getting the data to produce your applications. Now, as well as vital signs monitoring, I'm sure you would agree machines also need some attention. 38% of the global energy is consumed by the industrial sector, and about 69% of that is consumed by motors. Now, I'm sure you would agree it would be good if we can have these motors operating efficiently. To actually look at the health of motors, we can consider monitoring the vibrations. Analog devices provides complete solutions where you can actually monitor the vibrations of motors to look at their signature. And you can either have it in a wireless platform or a wired configured platform using single pair Ethernet, which my colleague Will would describe in a few slides. I would like to focus predominantly on the wireless platform. So similar to the healthcare patch, the Voyager 3 is a wireless low power platform that you can use for condition-based monitoring. This would actually allow you to look at the signature of the motor, so how it vibrates in the X, Y, and Z axis. And straight out of the box, it's calibrated, and it sends data again to the PC using Bluetooth. There's a graphical user interface as well, similar to the patch that I mentioned before. And one key benefit of using this particular solution is that it also shows off analog devices smart mesh network. So you can use multiple of these devices in conjunction with each other. So I don't know if you know how the mesh network works, but you have a wireless device, a network adapter, and you can extend that network by, let's say, hopping between different wireless devices. So if one is not in range of a network adapter, it will communicate with the nearest device to send that data on to your network adapter, which would then be sent to your PC. Now, I've mentioned a little bit about vibrations. You will know that analog devices, one of the key sensors that they design are accelerometers. So in the healthcare platform, the health care platform, as well as the vital sign, as well as the condition-based monitoring, you have accelerometers of different types. I use this opportunity to actually show you the differences. So this is the ADXL35X family, and you can have either, let's say, digital outputs or analog outputs. Now the differences would be a lot as such, but also the measurement ranges can go up to 40 Gs from as little as plus or minus 10 Gs. So if you are interested in understanding a bit more about these MEM sensors, you can meet us, on stand C5, is it C5 and E5, to discuss a bit more. I may have walked on a little bit about the health of a motor, but essentially, this slide is just a description of what you expect to see, right? A healthy motor would have a particular, signature in its X, Y, and Z axis using a 3-axis MEM sensor. The little blip on the right-hand side is an indication that something is probably going wrong, probably a bearing or something that's off. So using analog devices, condition-based monitoring Voyager 3 with the user interface, you will be able to capture data as well as analyze. I did start off by saying this is not a presentation on AI, but what are you going to do with all the data you capture? There is a Voyager 4 in the making, and this is going to take that data and use it to provide you with insights at the edge. So using that same device I mentioned before, the analog device's AI MCU, the MaxMT8000, it then takes that data, does some inferences, and is able to take action. So I'll now pass over to my colleague, Will, to discuss a little bit more about how we enable the digital edge. Thank you.
Good morning, everyone. Can you give me a thumbs up if you can hear me? Just so. Good. We've got microphones. Nice and positive. So I'm going to echo what Pierre said just now. We're not here to talk about AI, but one of the ways that we can enable this bridging the analog and digital world is bringing these MCUs and this AI processing nearer to the edge. Pierre has touched on the VSM, the vital signs monitoring, so measuring the characteristics of our own bodies and measuring the characteristics of industrial sensors as well. So like motors, you've mentioned, looking at imbalances, or maybe worn bearings which are causing friction, or even in renewable energy sources such as wind turbines or something similar, where we're looking to collate that data and make an informed decision. So many of the ways that we can do that is using these edge AI processors, which what they do is they allow us to make that informed decision at the edge without having to pass all the information back, whether that's through a power-hungry wireless signal or wireless communication network, or if we're using a wired one, we're having to run meters, tens, if not hundreds of meters of cable to be able to take that back to our main processor and then analyze and make that decision. So one of the ways we can do this is by having something like a MaxMT8000 to do this level of inferencing. It is, I'm not going to be, push the envelope here, but it is a low power and it's a simple AI processor. So some of the things we suggest with it, or some of the initial applications, you're looking at classification, so simple binary. You're looking at object detection. I think the devices that we offer up to about 9 different object detection, and this is in scenarios where maybe you want a wake-up system for a larger either face recognition or security system. As much as we love a motion detection system, if there's either a branch blowing by or a leaf, and that wakes up the system, that's using up energy that doesn't have to be used. And it's something as simple as detecting a human being that's moving around the perimeter of a location, a secure location. And these kind of applications where that additional low power, not power hungry and highly efficient products can kind of come into their own and offer an increased level of intelligence in these applications, which in turn will then wake up the larger system that can then be used to identify and understand what threat is around. Anyone who was here last year and heard me waffling on, this is the same slide as you will have seen. The idea here is more talking about the latency. So we are, not only are we looking at bringing intelligence, but we're offering decision making almost in real time. So what we have is a comparison of the Max 78000, the lower end of our AI processor, a standard Maxim Micro, and our competitors with one of their M7s. And I'd like to for the keyword search, which is our first row of the table, I'd like to draw your eyes to the millijoules, sorry, not the millijoules, but the milliseconds it takes for each of these products to be able to run the 20 keyword search. Now, in numbers it may not look much, so please look at the inference times on the screen. Hopefully this gives a visual example of why this kind of real-time information and real-time decision-making is a step up from what we understand. Standard linear MCUs are able to do the same kind of processing, but the time and the energy it takes is significantly more. So as much as they can be used, as we're ushering into a new age of IoT, we're looking at lower power, we're looking at renewable resources. Something like these Maxim devices may be essential in increasing our battery life and allowing us to make decisions, whether it's IoT in the homes, whether it's in the newest form of industrial automation factories that are being made with Industry 4.0. It creates a new lease of life for the technologies we're able to access. Kits on the board, it's a very simple slide. It's showing you what's available. These are all the kits that we offer that you can get your hands on. I will be honest, there is a learning curve. If you don't already have in-house knowledge of using the tools that are required, such as PyTorch or TensorFlow, there is a level of learning and understanding that people have to do. But we have the available resources here. So we have the two big eval kits. We even have the feather boards for people who are looking at the very low level monitoring for industrial purposes or even audio. All of these kits offer multiple interfaces that you can use to start your AI journey that are easy to get to grips with, and there's suitable amounts of information on how you can use that online, and we can obviously help support you with that. This covers a range of solutions that maybe ADI is known for. I will ask you to ignore the bit in the middle that says smart catheter. I'm not offering a smart catheter here. I'd rather just focus on the bits around the edge, so apologies for that. But ADI typically are known for the likes of pressure sensing, some of our A to Ds that we offer in the name. We currently have one of their latest award-winning products on our stand. The power solutions, the isolation, maybe a little bit more now, the secure medical devices. Again, we've got some fantastic cybersecurity examples at the moment on our stands. But maybe not so well known is their data communication, and it's this kind of connectivity and interface that I'm going to talk to you about next. GMSL is a serializer, deserializer product. It's called the GMSL, or Gigabit Multimedia Serial Link, and it comes from the automotive industry. So it comes from the first infotainment systems that were ever produced, maybe we think it's about the early 2000s, and this was produced and made by Maxim. What we've seen is more and more we need high resolution displays that are taking information from the sensors all around the car, whether it's the camera in the front, the back, monitoring of the passengers, and being able to transfer large amounts of data quickly, deterministically, and in high resolution. Obviously, in the UK at the moment, there isn't as much maybe automotive applications, and we're starting to see the branch out now. One of them, or the main sectors we're looking at, is in healthcare. So we're looking at the likes of medical tools, surgical robotics for keyhole surgery, and these products are allowing us to access levels of resolution for video that maybe weren't possible through the use of the interface they offer. So you can use a simple single twisted pair or coax cable to transport GMSL2. I'll move on anyway, but GMSL2 offers up to 6 gigabits per second of 3K resolution. GMSL3, which I believe is either due to be released or has been released now, will offer up to 12 gigabits at 4K. The product is video splitting. You can daisy chain them. There's data aggregation for other applications. We're seeing a lot of applications in time-of-flight sensors. So if you're having several time-of-flight sensors, you want to bring that video feed into one single chip before transferring it. GMSL is offering that option, and you're looking at low-cost, backwards compatible devices that share a similar footprint. So whether you're starting to get used to GMSL2 and you want to upgrade, there is that flexibility with the devices we offer. A simple comparison that we have with GMSL and a competitor, this is more just to give you an idea of the specs that are available and what it means. So whether it's the increased bandwidth that they offer, the power that we offer with a 1 amp offering over 150 milliamps, a very low bit error rate. The automotive industry is obviously quite unforgiving in its stringencies around the transfer of data, and all of this can be used to create highly redundant and reliable products. And then I've just got a bit of an overview of the family. We offer single, dual, quads products, and again, this is all GMSL2, so it's something that we offer the upgrades and are very similar if you are going to be moving forward with the product. 10BASE-T1L, so industrial Ethernet, which I'm sure many of you have heard of. Ethernet is a fantastic solution for being able to move large amounts of data. We obviously have power over Ethernet now, which can power these edge products in industrial sectors or within large-scale enterprises such as hotels. Ethernet's fantastic because it's ubiquitous, it's relatively well understood, and the bandwidth is what people are looking for. The issue we find with the industrial customers is the reliability, the time, deterministic latency is obviously required for control circuitry, and this is where something like 10BASE-T1L comes in. It offers up to 1K, but the latest products will offer up to 1.7 kilometers in certain scenarios. It ranges from offering power of up to about 60 watts down to some of the intrinsically safe applications, which are around 500 milliwatts. So for those products that need to be certified by ATEX, this product will be able to give you that power and that data collection over a large scale. So this is our industrial automation factory example of how we can use industrial Ethernet to connect throughout these several different layers of the factory. ADI offer their two products, the ADIN 1100, which is our Mac PHY, or not Mac PHY, it's our standard PHY, and the ADIN 111. Both of these are low power consumption, can't speak at the moment, low power consumption, and enable access to the edge monitors, the edge processors and sensors, and can collect all the data and transmit it over a kilometer to your central processing unit. The ADIN 2111 is our industrial switch, so allowing daisy chaining of the products, removing the requirement of several larger devices for interfacing. And again, it just allows a greater depth of product throughout your industrial factory, so you're not having to have larger gateways, and it can be linked by a device. And then our machine learning, our machine health. So Pierre has already touched on the fact condition-based monitoring is something that's key. We're looking to manage the use of our industrial products, monitor them, and to ensure the health of them continues. You're not getting wear and tear that's going to cause a lot of expensive repair work. Wireless is fantastic. It's great if you've got somewhere that isn't got an existing wired network, or somewhere where it's not possible to maybe put wires or is less accessible. But for those factories where you've already got wires in place and you want to use an existing architecture, industrial Ethernet is something where you can use the existing twisted pair and can give you connectivity from sensor to cloud and allow you to implement that with AI at the edge if you so wished. This is an example of what we have on our stand today. We have our single pair Ethernet condition-based monitoring device, and it's just an example of how easy it can be to connect up industrial Ethernet with one of our accelerometers and actually have that just performing simple monitoring, which we are more than happy to talk to you on our stand if you are interested. That is a brief coverall. I appreciate that I've absolutely shot through that. And that is everything from us. I think we've got about 5 minutes now. If there are any questions, I will see if there's a mic. Right. If you've got a question, please put up your hand. No questions. Any general questions, ADI, Anglia related, that we can answer as well? No, fantastic. That's what we like. Well, thank you very much for coming. We are, as Pierre said, we are, I think, C25 and E25. We are Anglia. We're here with an array of products. We have our time-of-flight sensors. We have our Trinamic motor control devices. We have the new pressure sensor, which has recently given the Red Dot Award. Our cybersecurity authentication, which I'd absolutely recommend coming and look at. It's the best demo we've had in years. It's fantastic. We've had our millimeter wave, which is coming into that motion detection and human recognition. And then we have a couple of our silent switcher products, which may be of interest in those kind of highly sensitive environments. But otherwise, we've got Anglia, we've got analog devices on the stand. So please come say hi, introduce yourselves, and we'd be happy to support you in the future. But otherwise, have a fantastic day and enjoy the rest of Hardware Pioneers. Thank you.